Hi everyone. Good afternoon, good evening, good morning, and from wherever you are listening this podcast. Thank you very much for listening this. This is Coding Talks with myself Vishnu, and in today's episode, I would like to talk about the data lake concepts as well as some of the data aggregation strategies for business decision making that are undertaken by most of the organizations. Myself, a .NET programmer from Thiruvananthapuram. I have experience working with the different cloud vendors like AWS, Azure and GCP. If interested, please listen to my previous episodes in this podcast, as well as there is an YouTube channel which is as of the same name as this podcast, Coding Talks with Vishnu. In addition to that, there is a meetup group. Please sign in for free at the meetup group and join the meetup group Coding Talks Cloud Computing, where you will get notifications about the upcoming sessions about the different cloud technologies. I'm a community builder for AWS storage as well. So that's all about myself. And coming to the data, it's one of the most important part of every organizations. In this episode, we will walk through a journey from the basic data aggregation strategies to more complex aggregation strategies like the data lake, and finally up to the new trend in data lake called the Delta Lake as well. We will be covering an overview of all the different approaches that I'm familiar with and I have seen various organizations working on. Based on that, I will be presenting some of the ideas about data lake in this episode. So we'll start off from the basic understanding about how a small scale organization or a medium scale organization handle the data. Many of you already familiar that data is the core of every business. Most of the service-oriented companies or product-oriented companies, they will be having different applications as part of their organization, and mostly many of the applications do have their associated dashboard as well, which will aggregate the data and present the data in a meaningful way. The reason why these dashboards exist mainly because of the fact that these data are very much helpful in taking efficient decisions, especially for the senior management. This is one of the reasons why whenever a main decision needs to be taken, usually management insists some senior leaders or others to present the data in a more understandable matter, because based on the data they will be taking the decision. It can be a data about their product, how the product behaves recently, and also about how the outcome of any new recent product launch, or how the overall customers are reacting to their particular products. They also interested in reviews and all. So this way various kinds of data do exist there. And in addition to that, also from an organization point of view, sometimes for the audit purpose and all, there is a need for aggregating this data. Usually when such need happens, management approaches someone from the senior leadership or those who can do the data aggregation. So they will either do that manually by collecting the information from different softwares and then maybe present that in the form of an Excel document or some other meaningful format that others can understand. If it's in a kind of a complex decision, it mainly involves sometimes collecting the data and present that in the form of some dashboard charts like either a Power BI or some form of the visualization tools they might be using in that case. These are some of the typical scenarios. But altogether, if an organization has various branches across the world, if they are operating on a larger scale with a massive set of customers, then collecting the data in this fashion, especially the manual collecting of data and presenting to the management, is not a feasible one, because it will be time consuming. Maybe those who are listening this episode, and maybe those who are already familiar with how a manual aggregation of data and its process involves, they might know that it's not an easy task, because they might be busy with some other tasks, and in between they are getting an intimation from the management that they need this report and so on. So they will be in the process of aggregating that data and in the hurry of presenting that to the management. Most of the times that may not be an effective data presentation, which results in the decisions as well, which affects the outcome of the decisions as well. So for organizations that operating on a larger scale, the need for a efficient data aggregation is quite important, and that's one of the reasons why the data lakes are getting popular these days. From the smaller scale manual aggregation of data and presenting it to the management, you can think about data lake as a massive collection of data from across the organizations into a common data pool, so that the interested parties can work on that data lake. They can clean the data, they can aggregate the data, and they can even form subset of data that can be presented to the management so that decisions can be taken up. That is the concept of data lake. And in this episode, we will be looking at different ways by which we can ingest and organize data in a data lake. We will be also looking at some of the strategies like Spark and Databricks in the context of the cloud providers like AWS, Amazon Web Services, and Microsoft Azure. We also will be looking at some of the efficient ways by which we can how to store the data in a data lake using the newest Delta Lake format as well. While I present this episode as mostly focused on data lake, please keep in mind that data lake is just one of the solutions for presenting data to the to who are that are interested in that data. It cannot be considered as the final solution for all the data needs. The reason for this is that we will explain that as we once understand about the data lake. As an introduction, I will be letting you know that even though the data lake is an efficient organization of data, still it has its limitations, and that leads to some other different variations of data lake as well that we will be discussing as we go through this episode. Once again, thank you everyone for please tune in, and we can discuss more about the data lake. So after listening this episode, you will get a great idea about the data lake, what it is, and also about some of the technologies that are related to Azure and AWS that can help to build the data lake. You will also getting familiar with some of the ingestion data strategies that we are using to pull the data from various sources to data lake. So one of the key such technology or service that we are using from the cloud provider is one is the Azure Data Factory, and another one is AWS Glue. These services from the cloud providers can help to collect the data from various sources. Data can be from various sources. like in the beginning of the episode, we talked about the small scale organizations where some of the senior leaders might be collecting the data from some different software outputs, or maybe from some files, and then aggregating that manually using an Excel or some other tools. Similar way, when it comes to a large scale organization that spans across regions and geographical locations, then there occurs the need to aggregate the data from various sources. It can be the sources from something like the log files. It can be sources like social media streams where the customers are expressing their feedbacks. It can also from various software outputs. It can be from files like CSV or JSON. It can be from database, relational database. It can be from NoSQL. So different types of inputs. And also one of the recent trends like the IoT devices, that can also be considered as an input to this data lake. In the context of all these different inputs, it is evident that the data lake mechanism must be capable of injecting the data from various different types of inputs. So we will look into all of those things. And about the prerequisite for listening this podcast episode, there is nothing. Even if you are having a little bit idea about the data and its usage, still this episode will be helpful for you. And also those who are familiar with the data lake concept, for them the episode must be a refresher, I hope. It will be good to have an understanding about cloud technologies that can help you to better grasp the ideas that I present in this episode, but it's not a must. Cloud vendors like AWS and Azure have different services, and these services can help you to spin up these data lakes in their environments quite easily. You can also spin up an environment on-premise, though you need to think a lot about while setting up a data lake on-premise, because there is a limited scope for scalability and performance when it comes to an on-premise. And also the initial cost also must be high. So the trend is like most of the organizations are either going for some of the cloud technologies like AWS or Azure or GCP and many others as well. So that's just an overview. Now let's look into the different concept. In the beginning, we briefly touched upon the manual collection of data, and as that manual collection progressed and when the data becomes huge, there occurs a need for storing such huge data or a massive amount of data, and there occurred a need for storing that data in a database. Mostly in older days it's the relational database systems like a SQL Server and MySQL or PostgreSQL were the ones that most organizations relied upon for storing this data. But SQL Server or MySQL or whatever relational database management system we can call, Oracle or whatever, it has its limitations. It's not capable of handling massive amounts of data. So there occurred the need for a concept called a technology that finally evolved from the relational database management system, which is called the data warehouse. If you look into the cloud providers like AWS and Azure, you can see the warehouse technologies there, like the Amazon Redshift, and also in the case of Azure, there is Azure Data Warehouse, which is also known as Synapse Data Analytics. The earlier name for Azure Data Warehouse was called the earlier name was Azure Data Warehouse, and that later evolved into Azure Synapse Data Analytics. There is a limitation by which there's a limitation in using this data warehouse. One limitation is that we need to store the data in a predefined structure in a centralized repository. And that's the main thing, and this data must be in a relational format. Because that was the approach earlier used by software developers to store the data. Many of us are already familiar with the RDBMS, and we know how to store the data in a column and row format in tabular database, like the relational database. Because of that, when there occurred a need to handle massive amount of relational data, they evolved the data warehouse concepts. So the idea is that it's a small kind of a data lake where different data sources are cleaned up and stored into data warehouse. I remember a few years back, I have worked in one of such systems where we were collecting the logs from different systems, and we clean up that logs and store in a data warehouse called the Azure Data Warehouse, which is now called the Synapse Analytics. And once we store that data into data warehouse, we could pull reports from those data and can be presented to the users or the higher management to take effective decisions. It can also be a customer-based report as well, so that they can take the decisions as well. Here the amount of data or the scale velocity of data is too high, so we call that as big data, because even in a fraction of a second there might be thousands or lakhs of data that are ingesting into the pipeline. The traditional SQL database is not capable of handling this much loads, so there occurred the need for relying on data warehouse like Azure Data Warehouse. This Azure Data Warehouse has the capability to inject large amount of data using a technology called Polybase. The idea is we collect the logs from various areas and then store that logs into a common area, which is the Azure storage, which is the object storage service from Azure. And this Azure SQL Data Warehouse has the capability to read data from that Azure storage, and it can ingest the data very fastly than a traditional SQL database. It uses a technology called Polybase. The idea behind Polybase is that there is a controller node there and there is a worker node there, and this controller node identifies the type of data and the amount of data that we are going to ingest, and based on that it will parallelly spin up multiple worker processes behind the scene, so that those workers will be responsible for injecting the data parallelly. So the idea here is parallel processing. Instead of the SQL server which inserts the data one at a time, this works in the concept of like a parallel processing. SQL Server also has the concept called batch insertion, but this is much more advanced than even batch processing. This is a kind of a parallel processing. So this data warehouse has the capability to insert data as well as it also has the capability to export the data from SQL data warehouse, providing making it an efficient storage solution for reporting purpose. And also tools like Power BI has the capability to connect this with this kind of SQL data warehouse, so that efficient reports can also be presented to the users. So this is a good technology in cloud for presenting data to the business analyst and also for BI and reporting purpose. And this data warehouse is also optimized for data retrieval. because at the time of querying, it will also query the data based on parallel processing. So it's quite good for most of the initial needs that have occurred in organization for reporting purpose. But there are some challenges with the data warehouse. The reason for this challenge is that nowadays the velocity and variety and volume of data. So when these three are the characteristics of a big data type of data, where the velocity will be very high for that, and the variety of data. It can be data from IoT devices, it can be from streaming devices, and also it can be from other files or logs, and it can also be an audio or video file. So the velocity, variety and volume is also high. There is a massive ingestion of data that can happen per seconds. So 3 V's together form the big data, and recently the big data trend has significantly increased, and because of that, data warehouse is not an efficient solution for handling this big data. It can handle up to a lot with the help of this Azure Data Warehouse, Polybase and parallel processing, but still, because of the variety of data, we need some another mechanism. So while listening this podcast, you are understanding one by one the different technologies, starting from the manual collection of data, and now we have reached a stage where we came through the SQL Server relational database system and a higher variant of the relational database system, which is called the data warehouse. So still there is a need for processing large amounts of big data are significantly increasing day by day, and especially for organizations that span across multiple regions and different locations, they want to take effective decisions based on massive amounts of data in an effective way as fast as possible, so that effective decisions can be made based on that data. There occurred the need for data lake. So just like we call the data lake as a collection of different sources of water from different streams, similar way data lake can be considered of as a stream or aggregated collection of data. It's a massive collection of data from different sources. It can be the relational database sources, it can be the IoT devices, it can be the streaming data, and also it can be file logs or audio and video as well. So this way, various kinds of data can be aggregated, collected as it is, and can be stored in the data lake. So this is important. We are not going to alter anything because the data lake mechanism is capable of handling any types of data. It can be relational sources, it can be streaming data. So we will store the data as it is in the data lake, and from there we will be clean up that data, and then maybe can do one more cleanup so that it can be presented to the user. So the data lake, it's just like think of a common reservoir which can be served for all. Same way the data lake can be considered as an aggregation of data of different types which can be used as a reliable source of data and can be used by different persons in organization. For example, if you consider a large scale organization, there can be different kinds of users of this data that is stored in the data lake. One such users can be the decision makers like the BA or the management who are interested in different reports. So we can depend upon the data lake and can pull the reports for them. Similar way, a company is always interested to do innovations. So some machine learning kind of approaches they may be heavily investing in, or some kind of an automation systems they may be interested in. So this same data lake can be used for that purpose as well, for machine learning or other purpose, and similarly for data science and other application. This data lake can be depend upon. Similar way, So the different kinds of needs can be catered with the help of the data lake. So there lies the relevance of that. Earlier, when we were discussing about the Azure data warehouse, we understood that even though it's capable of handling more data than a traditional database, still it's incapable of storing the different varieties of data. The data warehouse is actually a columnar format which is optimized for storing and retrieving data. Still, it's not capable of storing the variety of data. So the variety is what the differentiates between a data warehouse and a data lake, where we can store the different variety of data there, which makes the data lake as a kind of a single source of data holding the vast amounts and variety of data in its raw format. So we are not altering anything, we are storing the data as it is. So it can store the variety of data at a very large scale, and also, like I mentioned earlier, the data are of different types, and one important such data is the streaming data, especially the customer feedback and all, which are coming from different sources like the social media, tweets and all, which are a kind of a streaming data that are coming at very high speeds. That also can be stored in the data lake. So when these different types of data were coming as it is from there, we don't have time to define a particular schema for those data. That makes an limitation, like we need to store the data as it is in the corresponding system. So data lake is capable of that. It can store the data in the native format as it is. So we can efficiently make it as store there. Then also, if you compare the cost associated with data warehouse and versus the data lake is much cheaper. Nowadays, say for example in Amazon Web Services, the S3 can be used as an efficient storage for this data lake, and which is much cheaper. And also for Azure storage can be used for as a data lake for storing the different types of data. It's an object storage, so it's capable of storing the different types of data, and it can also scale at petabyte kind of scale, and you only need to pay for the amount of data that you are actually storing inside the object storage and the time by which you are actually storing the data. So that for that only we needed to pay. It's like a pay as you go up kind of model, rather than see, it can scale up to petabyte scale. Like one storage account can store petabyte kind of data. The exact the limitation, it's like a kind of a it's petabytes kind of scale. So that means if for one single storage account you can have that much kind of scale, but you don't need to pay for that. You just need to pay for how much amount of data you're actually storing inside that. So that's one of the advantage of the Azure storage. And similarly the S3 as well, Amazon S3, that's also capable of storing that kind of data. And this is much cheaper when compared to data warehouse. When we were using the Azure data warehouse, it's more costlier than the storage mechanisms because it includes the parallel processing as well. Keep in mind that even when we are storing something in Azure storage or S3, still we need to process that and we need to incur charges for that. But still, when we compare the storage cost associated with the data warehouse and that of the this kind of Azure storage or S3, it's relatively cheaper. Then the other thing is that even though the relational database structure or the schema can be efficient for displaying the data for reports and all, still for the initial storage we must store the data somewhere in its raw format. And from the raw format we can analyze the data in a much effective way before converting that to some other format. So the data can be very much can be evaluated from the initial data that is stored in the data lake. So that makes data lake another benefit for the data scientist or whatever who are interested in the actual data. Also, this storing the data like this in the raw format in S3 or storage allows the different big data processing tools, like a lot are there in the Azure and AWS, like the Azure Databricks and AWS Databricks. Similar way, other data factory and other like Amazon Glue and all can use this data underlying S3 or storage data, and they can process it and curate data so that it can be presented to the user. So this way, a multiple of use cases can be satisfied with the help of this kind of data lake architecture. I hope you got an understanding about how a data lake looks like. It's a massive collection of data, massive collection of different varieties of data, and it is capable of storing any types of data at any petabyte kind of scale. Now we are focusing more inside the data lake and how it looks like, how we arrange the data there. So for easy understanding of data, there are different architecture out there in data lake. I will be mentioning about an architecture called the Medallion Architecture. You can search about this in Google. That will give you more insights into that. The Medallion Architecture is a kind of architecture where we split the data lake into 3 different layers. This is for maintenance purpose of data. So the initial data that we are collecting from different sources, that's called the raw data. And this is the data which we are using for further processing. We store that raw data initially in a layer, and that layer is called the bronze layer. So the bronze layer is the first layer. It's the area where all the raw data is coming upon. So we'll store that data there. It's the raw data. It's unprocessed data. We will store as it is. For example, if it's a log file, we will store the log files as it is there. Then if it is a kind of a JSON file, we will store as it is there. If it's some video or other images, we will store as that is. Then it can be some data from some kinds of log mechanism. We will store that logs as it is. Or it can also be kind of a streaming data where it has a timestamp and a streaming data associated with that. We will store as it is. And for IoT devices and other, that also we will store accordingly. Similarly, the tabular data, like the relational database management system data, we will store that in this format. This way, a variety of types of data can be stored there. And so that called the raw data, and we store that inside the bronze layer. So this is a single data lake, but we divide that into 3 different layers for the sake of maintenance. So this can be for the sake of understanding. This can be considered of as kind of a 3 distinct folders for ease of understanding at this stage. So just keep in mind that 3 folders like the bronze layer. So the initial data will be stored in the raw data folder. Then the second one is called the silver layer, where we actually clean the raw data that we captured in the bronze layer, and we transform the data. So we will store here more granular data, and we enhance the data with more info, additional info, like we maybe classify the data in a more meaningful format, and maybe for the sake of presentation, we may combine the data from different files as well. In the raw data area where we will be capturing the file as it is, so there will be multiple redundant files there. But when it comes to the silver layer, we will be cleaning and transforming the data in a more granular way. And finally, the gold layer, that's the final layer in a Medallion architecture in data lake, where we aggregate all the data, and we finally form an aggregate based on the business requirement, and we store that in a way which is optimized for querying and for BI, business analyst or reporting purpose. So this is the way. So this gold layer is where everyone is depending upon. Everyone is interested in that data, while the bronze and silver layer are used by much lower scale users of data lake. So the more senior managements and the decision makers are interested in the gold layer, where they get the final aggregated form of domain data from which they can take effective discussions. So so everything is there within the data lake, and the underlying mechanism for storing this might be can be Azure Storage or Amazon S3. We will, as we progress in the episode, we will also look upon the different types of Azure storage, and also in AWS the ways by which we can store this data. Basically, it's S3 in Amazon, and for Azure, for the case of Azure, it's Azure Storage. We have understood the Medallion architecture here. Now, the another question that comes at this stage is like how many data lakes we do want in an organization. It depends upon the need of that organization. So there can be a single data lake for the entire organization, and which is called the centralized data lake. And there is another kind of architecture by which another kind of data lake approach by which we can instead of a centralized single data lake, we can form multiple decentralized region-wise data lake. This is easier to understand. Say, for example, if your organization has branches across 3 different areas, maybe one in US, another one in Europe, and maybe another one in Middle East. So in that case, you could form data lake for 3 distinct regions, so that it can cater to the needs of those regions. That is one approach, but having this kind of decentralized multiple data lake adds management overhead, because we need to handle the data lake, we need to run the associated processing and other units as well. Even in cloud, we need to form the wire up the pipelines and all to clean the data and all. So managing this becomes an overhead in the case of a decentralized architecture, whereas in the case of a centralized architecture, there is only a common data store, and it can be more easy. But you need to think about how effectively the decisions can make. Sometimes storing the data all in a centralized data lake may not be an efficient strategy, especially because there might be region-wise considerations as well. Also, the case of governance and also data security is another important thing. So in the case of Europe, there will be GDPR, like governance should be considered there. So compliance rules are there, that must be considered. While in the case of some other region, it might be different. So in those cases, the centralized approach may not work for data lake. So there the decentralized approach might be more suitable in that case. And the file format for storing the data, that also depends. It can store in a variety of format, but the most efficient way by which we can retrieve the data is one of the main considerations. Coming to the decentralized approach. So centralized means, hope you are clear with this. I am just quickly explaining everything and going on. Maybe I can a little bit slow down and explain each part a bit more, so that you will get a better familiarity. So when we consider designing a data lake, there are different things we need to consider, and we were discussing about the way by which how the data should be organized, whether we need a centralized database, a centralized data lake, or a decentralized data lake. So having a centralized data lake is suitable for small organization, and it is easy to manage the security, the governance, and also the data lifecycle rules and everything there for a centralized data lake. So it's not just about we simply store something in data lake and we pull out the reports, we clean up or pull out the reports from the data lake. There are lot of responsibilities also lies when we store the data in a data lake. One of the responsibilities is like security, because the data is quite sensitive. It can include sensitive informations of users. It can also include other sensitive informations like the GDPR and other things. So the thing is like we need to apply security at every level. In the case of cloud providers which provide these storage solutions like S3 or Azure storage, we can easily integrate those services with the underlying security service as well. Like in the case of Amazon, it's IAM, and in the case of Azure storage, it can be Active Directory. So we can apply the user policies and rules accordingly, so that only the authorized persons will be allowed to navigate inside to a particular area in the data lake. So that can be handled with the help of the cloud providers. If you are handling this on-premise by creating a data lake on-premise in your own hardware system, this security and also the governance principle must be quite challenging, because you need to handle all those things. Then another thing is the data life cycle. We were storing a massive amount of data. So there were times where we need to purge the data which are no longer required. And this kind of cloud provider systems like AWS and Azure has provided this data lifecycle management capabilities by which we can move the data from one tier to another tier, which can reduce the storage cost, and it can be enhanced for archival as well. This way, there are a lot of things we can benefit from adopting a cloud-based service model. Then there are some of the demerits that are there in the centralized data lake. One demerit is that everyone is depending upon a data lake, a centralized data lake. That means whenever you modify some schema or anything in the data lake, schema is not there at the bronze layer, but must be there in the some other layers like the gold or the previous layer. So at those layer, when you make some modifications in the data lake, if it's a centralized one, you need to be careful, because it might depending for other teams as well. So your change might break their service as well. So you need to be aware about all those things, and you need to communicate that for the entire teams. And it's not an effective way. Just like in the yesterday's episode about the Angular, we were talking about the modular microservice approach, where we can efficiently handle a single part of application without affecting the other part. This way, when multiple teams are working, having a centralized data lake can be quite challenging. And also for the case of global enterprises, where they have multiple establishments in different regions like Europe, US and all, different governance policy might need to apply. So centralized data lake may not be suitable for there. So in that case, you need to go with a decentralized approach, like a region-specific data lake. That is one approach you can. In the case of AWS or Azure, while you create those underlying storage services, you can have the option to store that or create that service on a region. So that's called the region-wise data lake. And also there is a customer-specific data lake can also be considered, provided if you are a service company or a product company which caters to different customers in different areas. So for those customers, you can create specific data lakes as well. You need to think about that, whether it is actually required or not. Based on that, you can create the data lakes. The benefit here in having a decentralized approach is that you can have separate policies for different users, different types of users and regions, and it provides kind of a faster development, and the tracking is also improved. You can, in the case of a global organization, this kind of region-based or customer-specific data lakes are more effective. But there, in the case of decentralized, there involves the management overhead, and if you don't properly manage all these things, it can result in kind of an data lake which no use at all. We will be storing a lot of data in all of these different data lakes, but the output we are gaining from those data lakes, if it is zero, then it might not be a useful data lake, and that can turn into data spams that you need to consider. Then while we store the data in the data lake, we earlier discussed about the different layers, like the raw data we store in the bronze layer, then the enhanced data which we will store in the silver layer, and also the curated data we store in the gold layer. So in the raw data, where we store the data as it is, which is coming from different streams, we can store that in the native format. Some of the native formats that are familiar might be CSV, comma separated one, then the JSON, then it can be Word document or Excel, or it can be video or audio or images, whatever it can be. Then on the second layer, we will be further enhancing that raw data to make it more presentable to the next layer. So that's called the silver layer. So there we store in an optimized storage format called the columnar format. So one of such columnar format is called the Parquet. So if you search about Parquet in Google, you will get a lot of details about Parquet. The reason why we are having the Parquet is that while the initial raw data format like the CSV or JSON is quite a simple and common format, and it can be used by many of the underlying tools like the Excel or Google, but still it has certain disadvantages having storing this data in the form of native formats like a CSV. The reason is that when we are moving into cloud and we are using some other services, the amount of data that is scanned per query will be charged accordingly. So if it is a CSV data, it involves a much higher cost than that of the other format like the Parquet columnar format. Also, if we are storing a CSV file, it consumes a bit higher storage space than that of the Parquet format. So the Parquet format that is developed by Apache Foundation has helped its users to reduce the storage requirements when it comes to a large data sets. Also, the scan time and deserialization time reduces, the scanning and deserialization time improved a lot. So overall the cost must be reduced, and also the processing also gets speed up. So you can search about go about Parquet in the Databricks site, where they explain in table about how while we storing a Parquet format in Amazon S3, the cost associated is $5.75, while in that of stored in the Apache Parquet format, even for it's less than 0.01. So the scanning cost and other cost reduced dramatically in the case when we use the Parquet format. So savings is around 99.7% of the cost savings, and when the supporting systems need to scan this data stored in the S3 or storage, the initial if we are storing that in the CSV format, those systems need to scan more, and accordingly the cost will also increase. Also the query runtime also increases significantly. So that's the reason why newer data lake implementers are going forward with this columnar format like the Parquet, which provides effective storing mechanism. So feel free to check out about the Parquet format, Parquet, in Google, where you will get more information about that format. Then also the compression, the metadata and the fast retrieval of data will be more high if you store in the columnar format like the Parquet. Then on the final layer, which is called the gold layer, where depending upon the business requirement, might be your organization might have business analysts. So based on their requirement or based on the management or the final team who want your actual data, based on their requirement, you can have different formats, including the Parquet as well. So that's an optimized data we will be storing at the gold layer. We can also consider this as curated data, where we will store the data as it is there and then will be presenting to the actual user. It can also be presented to some tools like visualization tools like Power BI, or it can also present to some other tools like Tableau or something, where the management or the respective team can make efficient decisions based on the data. So we are discussing about how we store the files in Datalake. We are not yet reached to the area where we will be discussing about the processing of data, that we will be thinking about those things a bit later in this episode. Now we are focusing on how we are arranging the data in the data lake. So there are multiple ways by which you can arrange the data, and some of the design considerations we already discussed, like which format to use one, and about the different layers, like whether we need a centralized or decentralized. Also the folder structure by which we store the data is also important. So if it's an hourly data that is coming into the data lake, we can store that in a format like folder structure. You can call any kind of folder structure. It can be something like a orders, or something like a sales, or something like a target, or something, whatever way, and you can fill then the main folder followed by a subfolder called year, and then another subfolder called month, up to hour. You can create subfolders. So the idea behind that is, when you want to make some decisions based on those data, the topmost folder can be considered. Say for example, if you want to consider all the orders of this year, you can simply pull out the underlying data from that year folder. All the subfolders can be considered from the year folder. Similarly, if you are only interested in a hourly data based report, you can consider that from the hour folder. So this way, the organizations of data files in the data lake is very important, because that affects the way by which affects the time by which we can retrieve the data from data lake. Also, you can have another approach of organization, like you can have a sales by consumer or sales by product folder, and then arrange accordingly. Also, in the case of region-wise data lakes, you can have separate region-wise folder as well. Also, even if it's a common data lake for multiple regions as well, still you can have a region-wise folder structure there. Also, based on the confidentiality of the customer, like a P1 customer or a P2 customer, we can protect the data accordingly. Then based on different considerations, you can search. You can do a quick search in Google about the different organizing considerations or for data lake, you can find it there. The idea behind all this organization is that how effectively you can retrieve the data. So the initial one I told about, when we discussed about the sales and orders, so we can create subfolders by year, month, day and hour will be quite efficient. So this kind of approach you can see in the Azure DevOps as well, where while we create a team or a Scrum team, we can follow an approach. They are recommending to follow an approach by an year-wise, date-wise, month-wise, and then the date-wise kind of a naming structure they told to they suggest to create there, because that way we can effectively filter the data whenever we want to pull out the reports from there. So if you want to pull out the report for a year, we can take it effectively because we arrange the data like that. So that way in the data lake also we should consider arranging the data files based on how we want to retrieve the data. So from an organizing data file perspective, it can be something like, say for example, if you are storing the raw data, and if it's a sales table, we are pulling the data from the sales, and in the bronze layer, I mean the initial layer that we discussed earlier, we will be storing something in this folder structure format like orders / the year, then followed by the month, then the day, month, then the followed by the month, then the year, and then the date, and then then the actual file, maybe the sales or the target file .csv. And on the second layer, this is an example of a single case I am explaining here. So in the initial layer, bronze layer, we can store in this way. On the second layer, that's a silver layer, we will be storing the cleaned and the transformed data. So we will be storing the orders. Then we can filter it further. We can filter it further by customer or further by region, and then we can follow the same structure like a day, month and year, and then we can store the data in a Parquet format, which is a columnar format, which is more optimized for storing and retrieval of this kind of data. A big data kind of processing, and also the underlying systems that are depending for processing this data can also benefit by using the Parquet kind of format. It reduces the cost as well. Similarly, on the final layer, the gold layer, which is the actual aggregated layer, where the other users are actually end users are actually interested to make decisions. So there you can put something like the respective departments, you can put it. For example, if it's a management team who want to make decisions, you can create a folder structure like management / followed by orders, and then some effective naming conventions like the sales summary or the cost summary or something like that, and then the actual data in the format of CSV or whatever way the parties are interested in. A similar way, if it is for a HR department, might be if we are forming a data lake and we want to arrange the customer data and all, and then if we are providing that to either to HR or finance department for taking some other decisions, that also can be considered aggregately. The main point is that there will be 3 different layers in data lakes: bronze layer, silver layer and gold layer. And as we progressed from bronze layer to silver layer and finally to gold layer, the data will be more effectively aggregated so that end decisions can be made out of it. Then the other important thing is the cost effectiveness, which is not a problem in cloud systems because we are only charging for what you are actually using. And also if you use the columnar file formats like Parquet, there won't be much problem in that. Also these systems like the cloud systems like Amazon S3 or Google Cloud Storage or Azure Data Lake Store, which is an enhanced version of the Azure storage. So there all, it is actually a single account can store petabytes kind of data. So it won't be a problem. So it provides high performance scalability, and also the availability is also very high. So S3 is one of the initial service that is started by AWS next to the EC2 service. So, and it became an effective service, and we become massively popular because the data is a crucial thing in every organization. So we can store the data massively in services like S3, which can scale up to any limit, and it's also very cost effective, cheap, and also very highly it's also integrated. The security is another important thing that is also handled in the cloud by the cloud providers, because in the case of the cloud, we do have the option to create the role-based access control, or we call that RBAC or Azure Identity, or Amazon Identity Provider. So all those things we can create different groups and associated users, and we can associate that with the underlying storage mechanisms like S3 or Azure storage. So that means our data lake can be protected, so that only the authorized persons will be having access to a folder. Say for example, in the case of gold layer in the data lake, where the final teams are actually interested in data, but only the finance team will be having access to their folders and not the other one. So that way we can protect every part. We can provide more granular control by using the cloud systems. In another way, we can simply think of like this, for the sake of security and how we apply that in each different layer. This bronze layer or the initial layer can be limited to just the data engineers, and the silver layer, next layer, which is a more refined layer, we can provide the complete access to data engineers and also read-only access to other machine learning engineers or data scientists. Similarly, the gold layer, which is the final output layer, we can provide complete access to data engineers and read access to other users. So this all things, if you implement this data lake in a on-premise system, you need to think about all those things, including the governance and everything, this role assignment, the security and all things. It's quite challenging if you develop a data lake in an on-premise system, where that won't be a problem if you depend on a cloud system, because these things are already handled, provided if you are ready to pay the amount for that. Then while designing the data or defining the data lake, another important thing to consider here is we need to think about the security. This is related to the security. Along with the RBAC or the group assignment and limiting the access for each personnels to a particular folder where they are actually interested in, we also should monitor the data, where who is actually reading by which folder is actually reading by whom and at what frequency. So we should depend upon the storage logs for such information, because the data is very sensitive and also it's very important. So we need to think about who are actually interested in that data, and based on that we should improve the data lake periodically. So it's not like an one-time creation and then forgetting about it. We need to constantly monitor the data lake and make effective implementation, updations periodically based on how actually the users are actually using. Sometimes while initially we defining a data lake and associating some users. Later might be that user will be moving to a different department and so on. So we need to ensure that whether that user has still a right to access a particular folder. If so, we need to rethink about that, and we need to reapply. So all these things must be automated so that whenever a person moves from one department to another, that the underlying data policies also apply in place, so that it also can be in place for the data lake as well. Manual applying of policies and removal is not suitable. Some organizations are actually doing that kind of way, by which there is a support ticket and someone will manually apply a policy, but that is not an cost-effective strategy. And it also consumes a lot of time, and there will be scope for more errors as well. Automation is the recommended approach which needs to be implemented while implementing a data lake, so that this kind of things can be drastically reduced thereupon. Also, finally we are actually storing the data in data lake, but take the case of a global organization where they have multiple regions and lot of customers and sales and orders. Data lake can become within a short period of time, it can become massively high, so that the interested parties may not be aware what all data are there in the data lake. So effective data capturing or catalog mechanism also it needs to be in place. Like say for example, some things like who owned this particular folder and its data, when was it created, and what all data is there in that, what kind of users are actually can rely upon these things. So these all things are actually a kind of a catalog information which should be built on top of the data lake, which needs to be connected to the data lake, so that then the associated data will be useful for the users. So in this way, we covered an overall a great deal of idea about the data lake and how it will be. Mainly, it will be having the data, variety of data and high volume of data from different data sources. So the data sources can be IoT devices, it can be on-premise DBs, or it can be an Azure database, or it can be log files, it can be logs from the virtual machines. Whatever kind of data that are actually useful for forming a decisions can be pulled out from different area. Also, the data for the data lake input, we can also depend upon support of the tools like the Azure Data Factory, which we will discuss as a bit later as we go along. And then another tools like this SQL Server integration services, which are used by a lot of SQL developers. In the past, not just in the past, still many are using that. So the idea is like a SQL Server jobs can be created which can transform one form of data in SQL Server to a different format. So that is called the SSIS. So this data lake can also use that as an input tool, so that it can pull the data from there. So this way different kinds of tools, inputs can be collected, data lake can collect and store. Then once it's stored, actually we need to once we store the raw data, we need to clean it into the bronze layer, clean it into the silver layer and to the gold layer. So for that we can effectively use some underlying mechanism. In the case of AWS, where we store the data in S3, we can use underlying mechanisms like AWS Glue or AWS Databricks, by which we can use Spark behind the scene to clean up the data, and finally we will store the data back into the data lake. There is no mandatory requirement like we should store the data back into data lake itself inside a folder or something, but if it's okay and if it suits to our requirement, we can even store that to a relational database system or even to a some other data warehouse system, like the one which we discussed earlier. So it depends upon the need of the organization, how we want to store the data. It can also be stored inside the data lake in a simple folder structure, so that interested parties can look upon. Then once we store anyway, everything related to the raw data, the partial cleaned up data in the form of Parquet, and then the final cleanup of data which is stored inside the data lake. Everything is there in the data lake, so it can be think of as an effective data store mechanism in addition to the operational store. So in a way, theoretically, we can say like, not just theoretically, even in reality, we can say like data lake can be considered as an effective operational store of data, but in majority of the cases, operational store must be separate and data lake must be separate, because data lakes, its purpose is to form the clean up the data and form the decisions based on the different operational data. So its purpose is different. So we use data lake for that purpose. So the final different kinds of data are there there will be different kinds of data will be there in an ideal data lake, and reporting tools like either the Power BI, Tableau or Excel can depend upon this data lake and form decisions. Also, other important services in cloud services like the machine learning services and Databricks services can also depend upon this data lake to form decisions. Also, analytical tools or Databricks tools or different other whatever cloud tools that are helpful to form a decisions, they all can depend upon the data lake as a common repository, as a final repository. So that way they can form the effective decisions. Then coming to the Azure, one thing needs to understand is Azure has Azure storage. The equivalent of that in AWS is S3, while the Azure storage, the initial Azure storage was started off like a performance oriented storage for storing the object, any type of data. Then to make it more compatible with the big data processing and all, especially to make it compatible with the HDFS, which is a big data processing format, and to provide more fine-grained permissions on top of the Azure storage folders, a second level kind of Azure storage is formed, which is called the Azure Data Lake Gen 1, which is followed by Azure Data Lake Generation 2. So the thing is like, if you are creating an Azure storage, if you want to use Azure storage as the underlying mechanism for data lake, what you need to ensure is that while creating that, make sure the Azure Data Lake Generation 2 must be selected, so that the underlying data storing mechanism will be compatible with the HDFS format, which make it reliable for the big data processing. And also individual nested folders permission can also be assigned based on that. In the case of AWS, it will be S3, and they have integration with all the different big data processing systems underneath the scene. So there, that won't be a problem. Then this storage mechanisms, like whether it's Azure storage or AWS S3, it have a lot of features in addition to the object storage. It's not just a simple storage of data. It's a storage of data. It's a performance oriented, scalable, highly available object storage with lot of other options as well, like the lifecycle management is already handled there. That means if you want to move a certain set of files which are not accessible for a period of time to a different layer, which has different tier which has reduced storage cost, these services do provide the option to move that. It's called the lifecycle management. If you search for lifecycle management in Azure and AWS, you will get an idea of that. Also the replication, like if you want to replicate it across different area, you can also have the option that, like there are different replication mechanisms are there. One is the locally redundant storage, where there would be stored in one region, and the data centers used underneath it will be one, while in the case of a zone redundant storage, it can be stored across 3 data centers. A same file can be stored across 3 different, same object inside a storage can be stored across 3 different data centers. That means 1 copy in each data center. So that means if one data center fails, another one can take upon. Also, the redundancy option is also there. So geo redundant storage, GRS, and geo zone redundant options are also there. These all options are there. You can see at the time of initial creation of Azure storage, or in the S3, the equivalent will be there. While creating this, you can have those options, or later you can modify that as well, I believe. I mostly at the time of initial creation, we will be forming a decision to whether we need to have a geo redundant storage or not, and accordingly that would be created. So these are some of the things which we covered when related to the data lake, the underlying designing the data lake. Then the second thing is, once we design this kind of folder structure and all, next we need to finally pull the data from here. So until now we were thinking about some of the considerations we should have, how the folder structure should be there, and what all different layers we can have inside a data lake. But till now the data is not there. We need some mechanism to pull the data. So we understood that data when I explained data lake, or if you are not still understood about the data lake, from my explanation earlier, it's actually just a simple data store only with massive scalability and petabyte kind of scalability. But it's up to you to pull the data from somewhere and make it ready for data lake to store. For that, we need to use some dependency services. In the case of Azure, it's called the Azure Data Factory, which we can use upon. You can also do some other way, like if you have a Azure storage and a folder structure created upon, you can use some other native mechanisms. Somehow you need to make the data available into the data lake. That's the thing. But this Azure Data Factory is a kind of a code-free. It's kind of a drag and drop approach and fully managed. Everything is managed by Azure, and it's kind of a serverless data integration service. The benefit that this Azure Data Factory and Azure Glue provides is that you can copy the data from various sources, including you can copy from an IoT source, or you can copy from a relational database. You can even copy from EC2 or virtual machine instances. A similar way, various kinds of 90 plus sources are available in the case of the Azure Data Factory. Also, you can have the provision to transform the data inside Azure Data Factory. Keep in mind that the transformation facility that is provided by Azure Data Factory is a kind of a basic to medium transformation of data, which is based on Spark. Actually, you can do some transformations. You can set the transformation logic inside Azure Data Factory, which can which will be behind the scene work with the help of Apache Spark to spin up parallel processor nodes and do the processing, so that with the help of parallel processing it can achieve the task. So this way, the services like Azure Data Factory and AWS Glue can copy the data from different sources to your data lake folder, and then finally they can they can also transform the data using the underlying mechanism. See, one thing you need to keep in mind here is that Apache Spark is the actual one behind the scene transforming the data, and in Data Factory the transformation capability that Azure Data Factory provides is very limited. It's not that much limited, but kind of basic to medium kind of thing. So that means if you want complex data transformations and want to do industrial or organizational kind of data transformation, you should depend on a separate service called Azure Databricks. So Databricks is based on Spark. This Spark is actually a kind of a parallel processing system where if you provide something to process, like if you want to convert a CSV format to some other meaningful format or something, you can instruct the Spark to do that. Spark behind the scene has two things, like it has a worker node and it has a controller node. So controller node receives the input and it will be provided to multiple worker nodes based on how much data you will be actually having. So if your input folder, like say for example sales / a particular date have this much, say for example 7 million rows, then if you are instructing the Spark to do that transformation either using Azure Data Factory's inbuilt transformation, or even you can use Azure Databricks transformation. There what it do behind the scene is, based on the input data, it will spin up multiple services and finally form the data. Spark is not part of this episode. I will be covering Spark in a different episode later. Basically it do parallel processing and it will finally able to store that data either inside some other service, or even it can store inside the Azure Datalake as well. So earlier while we discussed about the different layers in Azure Datalake, we understood about the silver layer, which is the medium layer, which is the actual Parquet layer. So the transformed data can be stored there. And finally, we may need to do one more transformation of data, which can be effective for the final business users. So for that, we can use the same Apache Spark or either inbuilt or the Azure Databricks based one, and then finally we can store the required data in the gold layer. So the Azure Data Factory with the combination of Azure Data Lake, like the Azure Data Lake is in fact the underneath the technology is Azure Storage, and in the case of AWS it will be S3 storage. So on the top of that we need to use either Azure Data Factory, or in the case of Amazon it will be AWS Glue, or even you can use S3 Lambda as well, or Azure Functions as well, to transform the data based on how you want to transform the data. And then we can store the data in a final folder. This kind of services like the Data Factory and AWS Glue are capable of orchestrating the workflow as well. So if you have complex workflows that need multiple transformations of data, that also can be effectively done with the help of this Data Factory. See, the thing is, like, once you have stored the data in S3 or somewhere in a kind of a scalable system like Azure Storage or S3, either with the help of an Apache Spark, like the Apache Azure Databricks, or the Azure Data Factory, or whatever way we can transform that. But Azure Data Lake by itself is simply a kind of a data storing mechanism only, which cannot have the capability of doing anything. So Data Lake by itself is simply a data store only. It's a conventional, it's a kind of a organized form of data only, but the compute node or the computation part is actually handled by either the Azure Data Factory or AWS Glue, or it can also be done by some other jobs, manual jobs, or even by Azure Lambda functions, serverless functions like a Lambda function, or the Azure functions, or whatever way you can. But keep in mind that the most cost effective strategy is what mainly we should consider. So that's one of the reasons why we are depending upon the Azure Data Factory, because it's one of the code-free, fully managed and serverless data integration service. It's actually code-free. Code-free means we can simply drag and drop these workflows and integrate that. If you open the Data Factory, inside Azure, it's you can see like there are different input connectors there. Similarly, output connectors are also there. So you can connect the connectors to different sources or destinations, and finally you need to write the actual code, or write or drag and drop and make a flow. Like there are different activity connectors are also there. Like if you want to copy the data from one source to another, Azure Data Factory provides the provision. You can drag and drop and put a activity behind in between an input and output, and it will do the copy of data. We can control what all data we want to copy and all. Also the transformation part also, we can write some code using Python or SQL, and that also can be handled. Python or SQL or R, these all are supported, and that also can be done with the help of a data factory. And you will be charged only for the amount of time you actually running the Azure Data Factory pipeline. So the pipeline running time, the pipeline means it includes the copy pipeline or the transformation data pipeline or orchestration pipeline. So these all will be charged according to the time you will be actually running. In the case of transformation of data with the help of Azure Data Factory, an extra charge for transforming using the Spark will also be calculated behind the scenes. So it's almost identical whether you use Azure Databricks separately or transform data using the Azure Factory. Both are almost similar, but Azure Databricks, which is based on the Apache Spark based clustering parallel processing, which is a bit more higher kind of tweak you can make using Azure Databricks. And also in AWS also, AWS Databricks is there. Databricks is a company which is formed out of the Apache Spark, and then they optimized the processing, so that's called the Databricks. So all the cloud providers like AWS and Azure have integrated that into their service, so that customers can use a managed Databricks service from either of this Azure or AWS. And it also provides a code-based approach where you can define the runbooks inside the Azure Databricks, where you can define multiple or single runbooks, and different flows can be also mentioned there. Flows means if you want to convert from one format to another, you can manually do that there. So these are some of the things that I like to present here in this episode. So thank you everyone for listening this episode, and next episode we will be diving more deep into using the AWS Glue as well as the S3 storage for forming a data lake with AWS architecture. So thank you everyone for listening this podcast. Have a great day ahead. Sorry, one more thing to mention here before we are winding up the episode. When I mentioned about these data lake concepts, you understood that it's a kind of a centralized database, and then centralized store, and then we will be creating multiple layers until the gold layer, and on the gold layer we will be serving the actual customers like the Power BI analyst or data scientist or whatever who will be interested in that data. Can be management or whatever. But the reality is that when data lakes are implemented in most of the organization, there are instances where managing the data lake can be quite challenging, especially because when it comes to a centralized database, the quality of data output that is retrieved from the data lake depends upon the quality of who form the pipelines and the effective cleanup of data. So the reason for that is due to the data engineers who are actually doing cleaning up of data may not be that much confident with the data that they might be working on, or the actual users who are interested in getting the data. So they may not be effectively communicating that to the data engineer. So this way, managing data lake will be quite challenging sometimes, and it can also result in a kind of a data spam where we have a lot of data in data lake, spending expenses for the data storage and all with no useful decision making data at all. So so in that case, there is an alternative approach to data lake also there, which is called data lake as a service. So in this way, in this data lake as a service concept, the idea is like every team who will be managing the data or a particular data will be responsible for creating the final data that are required by the analyst. Say for example, in the case of a Spotify, where the customer section who is responsible for creating playlist and all, they will be having an idea about the different taste and preferences of the actual users. So they can effectively create a playlist rather than from a data lake where a data scientist study all the different facts and then coming up with a discussion. So the corresponding team who is more into that particular domain will be responsible for creating the data output that are then finally stored into the data lake as well. So such a concept also exists. Just for the sakeness of completion of this episode, I mentioned that here. Also in the case of there's a new approach called the Delta Lake, which you can search in Google. So Delta Lake is kind of an open source storage framework that enables building a kind of a lake house kind of architecture with the underlying engine including Spark, Flink, Trino and all. So the benefit of key feature of this Delta kind of approach is that it is based on that Parquet format, and it's a lot of metadata is also can be added there. So the asset kind of transactions can be enabled there. So this can help to protect your data with the serialization and with the strongest level of isolation. Also, the scalable metadata is supported. So this can help to handle petabyte scale of tables with billions of partitions and file width. And also the time travel can also be enabled in a Delta Lake, Delta Lake is an enhanced version of Data Lake where we can easily revert to an earlier version of data for audit, rollback or reproduce purpose. So there are other benefits as well, and also the case studies about Delta Lake can be found there. So these are the one which I discussed earlier, like the Data Lake as a service where the teams are responsible for actual cleanup of data, or actual curation of data to be precise, I would say. So such kind of the teams who actually own or more related to that data should be the one responsible for creating that data. That approach is called Data Lake as a service approach, where in the case of the Spotify example that I mentioned, the customer support team or the customer interactor team must be able to should be more accurate, can more accurately create the playlist rather than another department who work on a centralized data lake. Also, the Delta kind of data lake approach can be used, which can provide additional features like the asset, the scalable metadata and time travel kind of things. So just for the sake of understanding, I mentioned that. So thank you everyone for listening this episode. Once again have a great day ahead.